This is class 11th, chapter number 27, Hyperbola. We are discussing about hyperbola. Hyperbola is a conic section. What is a conic section? When you take a cone and a plane and this plane intersect at different angles to this cone, the figures which are being formed are called as conic sections. For example, ellipse is an conic section, parabola is a conic section. Similarly, hyperbola is also a conic section like this. So this plane, you can see the angle it is forming. If you take the axis, it's parallel to this. So how can we form? Because we know about parabola, so you can just take an analogy that you make two parabolas here, one on either side facing x-axis here, right? This is a hyperbola. There are two definitions of hyperbola. One I'm going to give you right now, that is, if you take any point, that is all the set of all the moving points or the locus of the moving point, because this figure you can see there will have two focus. You take any point, so the distance of this moving point or the locus of that point from the distance of this point from two focuses, d1, d2, if you take the difference of these two, it will be a constant. You can take any other point on this parabola, again take the distance from two focuses, take say d3 and d4, and take a subtraction, d3 minus d4, and you always have to take the modulus, because modulus means you are taking the distance, and they will be equal, and it will be equal to a constant. It will be a constant. This is the definition of a hyperbola. There is one more definition that I am going to give you later on when we actually prove this formula. So always remember, it will be a constant, any point, distance from two focuses, the difference of this distance will be a constant. This is what do you mean by hyperbola. Okay. Now let me tell you the formula. We have learned about ellipse. The formula of ellipse was x square by a square plus y square by b square equals 1. If you remember it, it was this a and b was major axis, b was the minor axis, x, y is the locus of that point. So ellipse and hyperbola, most of the formulas are exactly similar. Hyperbola, ellipse, most of the terms, formula, equations are same. Similarity you see here because the ellipse, the formula was having plus here, but in hyperbola it will be negative. That is, x square by a square plus y square by b square, that was in ellipse. Now you can make it as negative. X square by a square minus y square by b square equals 1 is the equation of hyperbola. So if you remember ellipse, we said one ellipse was horizontal ellipse, the major axis on the x-axis. The other one was the vertical ellipse, the major axis on the y-axis. But we'll call it here this as two other terms. We'll not call them as horizontal and vertical, but we have some other term, different term to name them. You can always call them as horizontal and vertical, nobody is going to say anything. But in mathematical terms, the left one, which you see as the horizontal parabola, is transverse. The right one, which is the vertical, is conjugate. Okay. So for the sake of convenience, let us assume that this point is the intersection of the coordinate axis, which is 0, 0. It will not be, because some center points of HK will be there, but for ease of understanding, 0, 0 is the origin. When you are making an ellipse or a parabola, what do? Because you are actually trying to find out the locus of the point. So whenever it is intersecting the x-axis or a y-axis, this figure, is called as a vertex. But for an ellipse and a hyperbola, there will be two vertex. So we will not call them as vertex, but vertices. Okay? No, two vertex vertices. From here to here, the distance between the vertex, if the center is origin, it will be A, this side, A, that side. So the vertex equation, or you can say the coordinate, will be plus minus A0. A on right hand side, A is on negative side. Every elliptical or the hyperbolic or parabola will have a focus. So let us say that this figure has two focuses, F1, F2. When we have two focuses, we call them as foci or foci. So now again, if you assume it to be some C distance from the origin on the right hand side and minus C from the origin in the left hand side, so you will call it as plus minus C. But I'll prove it that this C is equal to AE in our later discussion, AE. So by now you can just remember it's AE. Okay. Now I'll go to the, if you take to the y-axis, let me tell you the other things remain same as ellipse. 2b square by A is the latest rectum, right? Various things remains the same. There are different books which show you different formula, but we will try to only take one of the scheme, right? X square by A square minus y square by B square. So here if you see x square by A square, x square and y square has been changed. X square and y square has been changed, and I'll tell you what formula we are going to use for a vertical and a horizontal axis. Let me complete this vertical axis first. It was plus minus A0 on the horizontal. Vertical it will be because it is on the y-axis. So the x-axis will be 0 and y-axis will have plus minus A. This will be the same as vertex as we saw on the transverse one. So the conjugate will have plus minus A as y coordinate. Focus similarly we have, again x will be 0, and similarly what we have taken in the horizontal, which will be plus minus C, but as I said, this C I will prove it to be AE. So as I was telling about the formula, these are the list of transverse and conjugate. The first column is the name. This column, second column, is transverse, horizontal, transverse, horizontal, T I am writing. The third column is conjugate or a vertical hyperbola. Let me just draw it here for ease of understanding. This is a hyperbola, okay, horizontal, and this will be a hyperbola with what? It will be on the vertical axis. Okay, so x square by A square minus y square by B square equals 1. Here what we have done, we kept A square and B square as it is. We kept A square and B square as it is. We never changed it. Right? But the x square y square we have interchanged. What is this I told you? Plus minus A0 for horizontal, 0 plus minus A for the vertical. Foci I told you it will be AE0, 0 AE. Center 0, 0. Transverse axis, what will be this one? A, this is A. So it will be 2A. And I'm going to explain you how it will be 2B, what 2B means. It's always a confusion. So just for timing, just assume that this is the vertical axis distance, 2B. 2A, 2B for the transverse conjugate same. Okay. What about the eccentricity? Eccentricity, it will be under root 1 plus B square by A square. Here we have changed it. For vertical, it will be under root 1 plus A square by B square. A square, B square, we have exchanged, right? Directrix, no change. I'll prove it to you that it will be x equals A by E plus minus A by E on the other side. Because both will have two directrix will be there. There is a change here. All the tick I am showing is there is no change. They both are similar. There is a parametric coordinate also. A sec theta, b tan theta. For the first one, second one, we have b tan theta minus a sec theta. Now let me tell you about this fourth column. In some book, what they have done is x square and y square, y square by b square minus x square by a square they have done, right? So the position of x, a and y and b have changed. So only the thing will be it is vertical axis, so you'll get b, you'll get 2b as the transfer axis, under root a is 1 plus a square b square, foci plus minus be, directrix you have b by e, and the parametric coordinates will be a tan theta, b sec theta, right? So this we are going to discuss, because I'm going to actually now, in the next discussion, I'm going to prove this equation. How did this equation has come? Hyperbola equation, derivation, proof. As we have discussed already, x square by a square minus y square by b square equals 1. This is equation of hyperbola. And I told you what is the definition of hyperbola, that you take any point on hyperbola, its distance from two fixed points, that is focus 1 and focus 2. The distance, the difference of distance, you can take any other point, always the difference of the distance will be constant. This is one of the definition which we have earlier discussed about hyperbola. I also told you about two types of hyperbola, because hyperbola is quite close to ellipse. So this is transverse, which was horizontal ellipse, and this one, and let me tell you, most of the formulas, expressions will be exactly similar to ellipse. This one is the conjugate or vertical ellipse kind of thing. How does this formula comes? We are going to discuss this. All these which we have already discussed, you will be knowing how these formula, expression, terms have come actually. This equation we are going to derive. This is one of the picture I'll be using, and you have to concentrate here also sometimes, and we will be making this diagram. The initial thing is any conic section, whichever conic section is available, the definition is same for each of them. That is, the movement of the point or locus of that point from the distance of that point from a fixed point, which is focus. Let us name it as S. So a point is moving such that its distance from a fixed point, which we are calling as focus, and its distance from a fixed line, we are calling it as a directrix. So the distance of this point from a point and a line, right, the ratio has to be equal to some constant. If I call this point as P, which is moving, S is fixed point focus, and M is say a distance, PM is the distance of this P point from this fixed line directrix, then we have a ratio. That ratio is nothing but the definition of any conic section. SP distance by PM distance is equal to E. If the eccentricity is equal to 1, this conic section is going to be parabola. Eccentricity is less than 1, it will become, the figure will be something like this. It will be E less than 1, that means we are talking about ellipse, and when E is greater than 1, we are talking about hyperbola. Exactly hyperbola we are going to discuss today. So this definition we are going to use and also prove. So I'll do some constructions here, and you need to know one thing very in detail, how to internally or externally divide a line. So this I am pointing as a focus, which is a fixed point. I am making a line also, which I told you that these two are very important things. One is the fixed point, focus. One is the fixed line, which you see here also. The fixed line is a directrix. So let us draw a line which is joining these two and perpendicular, that is, we are having a perpendicular distance kind of thing. Let us say this line is ZK. K is the point where these two intersect. S is our focus. Now this KS, we are going to divide it internally in certain ratio. E is to 1. E ratio 1. So if I say I take any random line, want to divide it into say 2 is to 3, 1 is to 4 like this. So we have a point here which is A, such that SA by AK is E is to 1. So A is dividing this line KS, internally dividing, so that we can write the ratio in a form like SA by AK is E is to 1. So the A point is internal to SK line. So we are internally dividing it. Okay. So SA by AK is equal to E is to 1. E divided by 1. So we are internally dividing it through A. So cross multiply SA equals EAK. This is equation number 1. We are going to use it. Second situation. Now we are dividing this KS line externally. Dividing this line externally. So let us say that the point here is A dash. A dash. Okay, A and A dash also have, we'll find out some relationship between them. But for right now, I am extending this SK, we are extending it to certain point A dash such that there is again a relationship which is E is to 1. So SA dash by A dash K, SA dash total line divided by A dash K, that is the K extended to A dash, is equal to is to 1. As I told you, internal, external, you need to know how to divide the line. So again, let's cross multiply. SA dash is going to be equal to E into A dash K, E into A dash K. So now we have two equations and we are going to add them, subtract them, and two things I am going to get. I told you two things are very important, you'll just realize. We will add equation number 2 with equation number 1. So 2 and 1 I am adding. So before this, I have to tell you one thing. Just let me write the equation and then I'll go back. SA plus SA dash equals, left hand side we are adding, now we are adding the right hand side, EAK plus EA dash K. So this SA and SA dash, now take this A and A dash. A is the internal point of internally dividing, A dash is externally dividing. Okay, so I will have a point C. I am by myself putting a point C, which I'll take later as the origin or 0, 0, and this C point, which is the center point of A dash. Please remember, A and A dash are the 2 points we got internally, externally, and this, the center of this, I am taking it as C. C is the center of A dash, such that, because it is the middle point, if you take perpendicular bisector of A dash, you'll get C. This C point is what? CA dash and CA, I'm taking it as AA because it is the center point. So I'm saying AA dash is 2A, total AA dash, such that CA and CA dash are independently equal to A. So CA and CA dash independently equal to A, right? So CA dash, if you add, it will be AA dash, which you are taking as 2A. This point is very important because all other derivation will depend on this. Okay, now we have added these two. Now let us try to write SA as dash in different manner. SA, I can write it as SA, take whole, that is, SA can be written as CS total, and in just subtract CA. CS, if you subtract CA, you are going to get SA. Similarly, SA dash. Now, how to write SA dash? So just add CS with A dash C or CA dash. You're going to get SA dash. Now take E common from these two. In place of AK, I can write what? AK, this A and K. Can I write it in this sum form? CA minus CK. If you subtract CK from CA, you are going to get AK. Now A dash K. Similarly, A dash K from here to here. A dash K can be written as A dash C plus CK or CA dash plus CK. I'm just taking the parts and adding them, or taking the parts and subtracting them, so that we get this above equation. Now if you see, CS minus CA, CA minus CA, and CA dash are equal. They get cancelled because they are A and A. Here you get CK gets cancelled. So you'll get E into the CA and CA dash as what? They are A. So CA is A, CA dash is A. When you add them, you're going to get 2A. So just cancel these 2, you'll get CS. I'm cancelling 2. So CS will be equal to AE. CS will be AE. So C, if you take it as 0, 0, the point S, that is the focus, is AE, the distance. So coordinate of S, if you take C as origin, it will be AE comma 0. So I hope you got the idea. I wanted this focus point and I got it. I told you I wanted focus and I want this distance. I can have an equation of any conic section. So one thing we have got S point, which is AE comma 0. Now I am taking, I want the other parameter also, because I want to have an equation. So second thing I'm going to do is to subtract these two equations. I had 1 and 2. So I will subtract 1 from 2. That means 2 minus 1 I'm going to do. What are we going to get? SA minus SA dash minus SA equals E, take E common, and here you get A dash K minus AK. So whatever we have done in the first part, we are going to write it here. SA dash was CS plus CA dash. You remember? CS plus CA dash is SA dash, and takes minus, what is SA? SA we wrote it as CS minus CA, so it is CS minus CA. E, A dash K was what? A dash K was CA dash plus CK, is CA dash plus CK, so just write CA dash plus CK. I'm just taking what we have done in the first part, so I'm just taking it here. Minus, what was AK? AK was CA minus CK, CA minus CK, just write it here. Okay, now expand it, means open the brackets. CS plus CA dash minus CS plus CA equals E, CA dash plus CK minus CA plus CK. CS gets cancelled, CA dash is A, CA is A, it's 2A. Okay, CA and CA dash both are A. You take them as 2A. Now what about this CA dash CA gets cancelled? You will get 2CK, 2CK. So E into 2CK you can write. 2 gets cancelled. Take E in the denominator, you will get CK as A by E. CK as A by E. Now second thing also you wanted and we got it. CK is the distance from the center to the directrix. So the point K is A by E comma 0 if I take C as 0, 0 or origin. So both the points we have. Now I'm going to take you again to the discussion we had, that initially I told you any conic section means the movement or the locus of the point which have a fixed distance from a fixed point, a distance from the fixed point and the distance from a fixed line, the ratio is going to be E, eccentricity. So this point PXY I'm taking its distance from the directrix, which is PM, and the distance of this P point from the focus, which is PS. So SP by PM, this SP by PM is going to be equal to E. So SP is going to be equal to E into PM. Now we'll square it also. I told you this S point we just got as AE comma 0. And this, what about this point? We know from C to K it's A by E. We already know, we just got it. From C to K, the K point is A by E comma 0. If C is 0, 0, then K point is A by E comma 0. This point is A by E comma 0. Okay, I'm talking about this. So if I take any point X, Y, That means from C to that point it's x. From the origin, or say y-axis, the point is x, and this m distance I want actually pm. I don't want the distance of p from this origin. The x coordinate, and we have a by e as this point. So total distance is x and ck is a by e. If I want just pm, I can subtract ae from x minus ae, x minus ae, or you can say the c. See, let me tell you again. I am saying if I take this x from C to this total point is x. Total distance is x. And we want this perpendicular distance only. So we have extra ck. We have to subtract this extra ck, which is a by e. So if I subtract this x, means subtract this ae, a by e from x, I am going to get the perpendicular distance pm. X minus ae is p, perpendicular distance to the directrix. So SP is what? It's simple distance formula. XY is what we have taken, and S point is AE comma 0. This is AE comma 0. Now you know how to find out the distance between these 2 points. So I'm just squaring this. I don't want to deal with the square root, so I'm squaring it. SP square equals E square PM square. What is SP? X minus AE whole square. That's it, this minus this whole square, and y minus 0 whole square. I'm not writing y, it's simply y square, equals, what is PM square? What is PM square? PM I told you, x minus AE is the distance. Now square it. Okay. Now we are going to rearrange. And I told you earlier when we were discussing ellipse, I actually solved it. So I'm just writing it directly because we have done it already. You know how to do this. So x square by a square minus y square by a square into e square minus 1 equals 1. I have just rearranged, nothing else. Square, open, rearrange, where b square is equal to a square, e square minus 1. So this is your equation. This is the equation of hyperbola. X square by a square minus y square by b square equals 1 is your ellipse. We just rearrange the sp square equals e square pm square. And this is the standard form of hyperbola, standard form. If you want to find x from this equation, what are you going to get? Plus minus, I'm taking this equation only, plus minus a by b under root y square plus b square. If you want to find out y, how to find y, it will be plus minus b by a under root x square minus a square. So these are certain things. So we have various things here. We have symmetry here. Actually, I'm going to do in the next discussion, I'm going to tell you what are the vertex, what are the focuses, what is the latest rectum. Everything we are going to discuss in the next discussion. This discussion was only about finding out the equation, because by devising or proving this equation, we got to know all the focus now. It's elements of parabola. We are going to see them in detail now. Hyperbola, most of the things are equivalent to ellipse. This is the equation we have already derived. Even if you don't follow that derivation, you have not watched it, the important elements consist of vertices. Vertices because one is vertex and multiple is vertices. So you see these 2 points. Actually, we have made 2 cups. These are 2 parabolas. And this shape is called the hyperbola. So when we bind it with axis, coordinate axis, we say x-axis and y-axis, these 2 points where this curve intersect on the x-axis or the y-axis, these 2 points are called as the vertices, So we have this plus minus a comma 0. From here to here, it's 2a. If you remember, when we talked about ellipse. So in ellipse, we said that we have a coordinate axis from here to here. This is the major axis. Minor axis will also be there. So this is the minor axis. Here we will a bit change from here to here, from A to A dash. In this case, A dash A, if you see the rightmost figure, I'm talking about transverse and conjugate. This A dash A is the transverse axis, and what is the length? 2A. From here to here, A on either side, 2A. When we make a perpendicular, that is actually here we are talking about y-axis, and we mark a point which is of length B and B dash. Since C this is, so let us mark it here also, B and B dash. This CB and CB dash, these are going to be equal to B, Similar, I'm just equating it with the ellipse. In ellipse also we have minor axis, semi-minor axis. So here we have 2B. A line which is perpendicular to transverse is called as conjugate axis. I'll tell you why it is called as conjugate in the later just now. So in every hyperbolic, parabolic or ellipse, they will have a focus. In physics terms, whenever a light from infinity is coming, it is going to converge at the focus. So this focus, there are two foci. I proved it in the previous discussion that this point focus, if the 0, 0 is the center, this focus F1 and there are two focus actually. So the focus, because it is 2, I call it as foci or foci. There are 2 of them. So that is why if we want to point out the coordinate, it's C, 0, but C, I prove it to be AE, 0. Similarly, on the left side, it will be minus AE, 0. So let us combine them, plus minus AE, 0. And now coming to the directrix. Now if you remember directrix, any point you take, the distance of this point from the directrix, at any point, distance of this point from the directrix, at same point distance with the focus, the ratio is going to be eccentricity. So this directrix, we proved it in the earlier discussion, it to be A by E, that is, it is A by E far away from the center or y-axis. So the equation of directrix will be plus minus AE, 0. I'm taking either side together, I'm combining them. There is one more thing, center. Right now it's 0, 0, but it will be HK when we see the questions. Eccentricity. How do we find out the eccentricity of hyperbola? Eccentricity represented by E. See, this equation is in front of you. X square by A square minus Y square by B square equals 1. And in this equation, I told you when I actually derived this equation, I told you B square equals A square, E square minus 1, if you remember. So if we are interested in E square, what are we going to do? E square will be, you take A square in the denominator for B square. So E square minus 1 will be equal to B square by A square, E square minus 1. And then E squared will be 1 plus B square by A square. And E square, you don't have to do this, I'm just doing it, but E square will be equal to, and this B square by A square, I'm taking it. Let us multiply 4 in the numerator, 4 in the denominator. That is, B square by A square, multiply it by 4, denominator also by 4. So now you get 4B square by 4A square. Now you can write it as 2B whole square and 2A whole square. This 2B is what? As I just suggested, 2B is the conjugate axis by the 2A's transverse axis. So under root 1 plus CA square TA square is the eccentricity. 1 plus conjugate axis whole square divided by transverse axis whole square. Now coming to a very important question wise, it's latest rectum. We have talked about this in the ellipse also. Any line which is passing through the focus and parallel to the y-axis in this case. So if I make a line, this line is latest rectum and the length of this line is the length of the latest rectum. So you already have a formula. How to find out this point? From center or origin to this, we know that x coordinate is what? AE, because I am talking about focus at this point. This line is passing through focus. AE. I don't know the y-axis, y point. So let us say it is SL with respect to this figure. So I have x coordinate as AE and SL is the y point. But I know that this point is passing or is on the hyperbola. So I can just put it here in the place of x and y. A whole square by a square minus SL whole square by b square equals 1. So we have SL square equals, just I am rearranging it, S square equals b square e square minus 1. When we have e square minus 1, we know that b square minus 1 can be written as b square by a square. I can always write that. So in place of e square minus 1, I am replacing it with the b square by a square. Okay. After rearranging, whatever I got, I am writing b square by a square here. So this becomes b to the power 4, b raised 4 by a square. Okay. Now in order to find out this SL, which is the y-axis coordinate of the point we have taken, it will be under root, so b square by a. So the distance of from the focus to the point of intersection on the parabola is b square by a. Similarly in the lower part it's b square by a. So you add them or multiply it by 2, you will get 2b square by a. This is the latest rectum. Same is for ellipse, same is for the hyperbola also. Now one more thing I would like to find it here is focal distances. What are the focal distances? Take any point on the parabola. The distance of this point from the two focus or foci is the focal distance. If I take any point P, you have S and S dash. So if just keep it this mind, because I am going to give you the final result. So this distances, say you have S dash P, assume it to be D1, the distance D2 which is SP is SP, that is D1 minus D2. And I told you earlier, if you followed me, that the difference of distance of this point from the two foci will always be a constant, and that is the definition of an hyperbola, and that is equal to 2a. That is equal to 2a. So this direct expression you are going to use in the question. This is actually equal to transverse axis. Now let me take you to the conjugate parabola, which is a kind of vertical ellipse equivalent. So this conjugate means what? Let me take you back to complex numbers. If you remember a plus ib, this a plus ib, what is the conjugate of a plus ib? If you remember, it's a minus ib. The conjugate of a plus ib is a minus b. Same concept we can apply it here. We have the equation x square by a square minus y square by b square equals 1. And this is for the horizontal or transverse hyperbola. Transverse hyperbola. What is the conjugate? Multiply it by minus. Multiply it with a negative. So what do you get? X square minus x square by a square plus y square by b square equals 1. Now just change the places. Y square by b square minus x square by a square equals 1. And this is the equation of the conjugate hyperbola. So you have x square by a square minus y square by b square. You keep a square b square where they are. Just replace x square and y square. You are going to get the equation of the conjugate hyperbola. Let me tell you, the eccentricity is somewhat changed here. A square equals b square e squared minus 1. What is the latest rectum? It's not 2b square by a, it's 2a square by b. It's not 2b square by a, it's 2a square by b. So there are two changes which need to be emphasized here. Eccentricity and latest rectum for the horizontal or conjugate hyperbola. Other things I already told you when we discussed earlier, like the vertices here is again 0 comma plus minus a, because it is on the y-axis, so x remains 0, y is plus minus a. How about the focus or foci? It's 0 comma plus minus ae. Okay, and eccentricity I already told you, latest rectum we have done, and this is the equation you need to keep in your mind. One more thing, just one, that if it is not center 0 0, how about an ellipse with not this not having the center at 0 0, then it is some hk, some point which is not 0 0. How are you going to write the equation? X minus h whole square by a square minus y minus k whole square by b square equals 1. This is all about the hyperbola. Okay, thank you so much. Take care of yourself.